Hi, and welcome to the 5th video in the GIV video tutorial series. My name is Max van Wyk de Vries, and in this video, we're going to look at GIV's basic inputs. They're the inputs that you're probably going to be selecting on almost every run. So I'm going to go to MATLAB, and I'm going to open up the GIV user interface. Alternatively, if you're using the app, then you just want to click on the app icon. So I'm going to type GIV GUI initialize. I can press tab to auto-complete it in MATLAB. Press enter, and it's going to open up the user interface for me. Going to take a little moment because I just opened my MATLAB. It'll be on its way. Here we go. There we go. This is going to be the user interface that you're going to be familiar with if you've opened this at all. And this first page here, titled Required Inputs, is going to have most of the inputs that you're going to be adjusting every time you run this model. So I'm just going to run through it very quickly by clicking through it. The first thing you're going to want to decide is what is the path to your images folder. You can copy paste it in here. What I generally recommend is selecting it. You can just click on select and it will open a file selection dialog. And from there, I'm going to go to the folder that I created in the previous video with freshly downloaded Perito Moreno Glacier images. So it was in here. I called it pre-processing. And I'm just going to click on select folder when I've clicked on the folder. So then the path will be automatically loaded. Then the next step, if your files are PNG or JPG images, you're going to have to manually enter the corner coordinates. And the key thing to remember is that the minimum latitude and minimum longitude will be the lowest number always. So if you've got a negative latitude, the minimum latitude is going to be the most negative number. Just remember that, otherwise it will flip the image. If you have used GeoTIFF images, you can just completely ignore all 4 of these boxes and just leave this on yes. If possible, I recommend trying to do that. The time oversampling factor is going to be a parameter option which determines whether you compute velocities over non-subsequent images. For example, in this case, we have 4 images here. So with a temporal oversampling of 1 or no temporal oversampling, we will calculate 3 velocity maps. 1 between the first pair, 1 between the second pair, and 1 between the third pair. If we set a temporal oversampling of 2, it will calculate all of these velocity maps, but it will additionally calculate it between subsequent +1 pairs. So it will calculate it between the first and the third image, and between the second and the fourth image. And if we set a temporal oversampling of 3, it will also calculate it between the first and the fourth image. So the maximum temporal oversampling you can set is the number of images minus 1. That will result in you calculating velocity maps between all possible image pairs, so long as they fit within the time limits as well. I will show you that in a moment. And another way that you can check what temporal oversampling options you can use is by clicking on Analyze Image Pairs. It will pop up with a dialog box telling you it's running. And you can do this as soon as you've selected your images folder, because that's the only input needed. And you'll see this will pop up with a couple of graphs, which will show you for a given temporal oversampling value, how many velocity maps you can actually produce. So in this case, we're going to want to set a value of 3. Generally, you want as high a value as possible. Like, the more velocity maps you use, the longer it will take computationally, but also the better your final results will be. So ideally, set this as high as possible. This file name to save as is just the name of your run. So you're going to want to change that every time. So here I'm going to call it video 5. Be careful. If you don't change this between runs, it will overwrite your previous folder. So make sure you do remember to change your file name between each run. The parallelize code option will determine whether you run your image pairs in parallel. You will choose the vote yes, or not in parallel. You will choose no. Essentially, most computers have more than one core to perform computations these days. And if you choose to parallelize it, it will actually be able to calculate several velocity maps simultaneously, which can significantly speed up the calculations. In general, you'll get a speed up of about 2 times by just using any number of cores, and a speed up of 3 to 4 times if you're actually able to use 6 cores. So I would generally recommend parallelizing the code, as it will run a lot faster. But do be aware that this will use up a fair amount of your computer's resources. So if, say, you're wanting to run this in the background while you're in a Zoom meeting, you may want to choose no, just to conserve resources a little bit. But generally, this is a good idea to leave as yes. Then I'm just going to jump into the Advanced Inputs tab to look at one additional thing, which is the data options. We will look at the rest of these options in the next video. Also, be aware that details about each of these options are described in the GIV user manual, which I've recently updated for this version. So you can go and read more about each of these options in there. But for now, the last option that we just want to have a look at here are these data options. So you can choose a minimum year, which in this case, we're going to set 2020. And the maximum year is also 2020 because all of our images are from 2020. Our minimum month is 1. Our maximum month is going to be 2 because they're all from January and February 2020. And then I'm going to leave the minimum and maximum days as is. So just let it search all days in those months. And then these last 2 options, the minimum interval for image pairs and maximum interval for image pairs, are going to exclude images that don't fall within these bounds. So here, 0.019 years is approximately 1 week, and 0.05 years is approximately 9 months. So note that these are in years. So any image pair that has a temporal separation of less than a week will be excluded, which is sensible because image pairs with 2 short time separations usually have much higher relative georeferencing errors. And we're also going to exclude image pairs with a longer time interval here, because often images lose coherence. The glacier surface loses coherence over time. So after a certain number of months or years, you will no longer be able to track features. So this may be slightly on the shorter end for many glaciers, particularly slower moving valley glaciers. You may want to set the maximum temporal interval for several years. And equally for slow moving glaciers, you may also want to raise the minimum interval, in some cases to several months, because they are going to be very sensitive to noise. For Glacier Perito Moreno and most other fast moving tidewater or lake water glaciers, these parameters will be fairly suitable. Okay, so here we've set the key parameters. And the last thing that we need to do, unless we want to adjust any of the advanced parameters, is to press run. So if we click on calculate velocities, this will start the run. In the next video, we're going to have a look at the advanced inputs. I will wait to press run until we finish going through the advanced inputs in that video.